faster than everything else. So this was testing for the BAM H1 site though. And here are 4 uncut. And here where they were cut with BAM H1 and ND1, so there was 2 fragments. So we successfully extracted the BGA BG. So then after we did all that, we have P delta alpha NH plasmid and a PMA5 BGA-B fragment. So we need to insert them together to come up with a functioning BGA-B gene inside of a collect E. coli plasmid. So we DPN1 treated both of them to get rid of the methylated DNA, anything that existed from the original E. coli that they were in previously. Then we transformed them, plated them, wizard prepped and maxi prepped to get isolated DNA. And then we did a 15 microliter digest. With the P delta alpha NH, we used TSAT, and with PMA5 BGAB, we did not. And then after we did both of those, you have the P delta alpha NH with ND1 sal ends and the PMA5 BGAB with ND1 and BAM sites. Unfortunately, we couldn't get both cell sites, but BAM H1 will work because there's another BAM H1 site in the P delta alpha NH. Then we ligated them together with the T4 and transformed, plated, cultured, and found ones that worked this morning. So, and then so you have the 3-base cultures that we need, that he needs to do the rest of the experiments, and then we just need extra. Then we need to start the PCR and the error-prone PCR to start making changes in the beta-galactosidase gene in order to start seeing more changes and to decrease the temperature, hopefully some more. That's it.
A lot for a week and a half.
Excellent.
A lot of work.
It's a lot of work.
Any
You must have
questions
worked
for
Sunday.
Sam?
This Saturday.
Now I have a couple of questions. The place you thought did not work. What if it worked, but actually since you had changed the amino acid nucleotide sequences, the optimal annealing temperature has changed so much that you're actually not getting any PCR band, but actually they are exactly the right place where you're supposed to be.
So you're asking if it works at a lower, like, because we don't know if it cut right, if later it'll work at a lower temperature now?
It was probably cut right, but your annealing temperature has changed for the primer, because you would not work with the same primer. If you change the nucleotide sequence, sometimes you can have 10 degrees difference in the annealing temperature. So if you're using 55, what are you using?
We used 55.
55.
Yeah.
Suppose 65, and you're not going to get anything, but you have the right plasmid. You may just miss it.
Well, that may be possible, but since we know that the BAM H1 site would work also in the ligation, why go to try back and go try to do things that we can fix already? Like, I
So you fix the problem.
Yeah, the problem's fixed. So we have a working.
But always keep in mind that you may have fixed the problem previously and just not able to detect it because of just nucleotide rearrangement. When you're cutting, you are rearranging the nucleotide and you may not have annealing in the right place. So what do you do? Suppose you have this situation, you have this in your mind. I think it didn't work, but that's beyond the point. But suppose you think it didn't work, but what you would do, what technique you use to figure that out?
To figure out if it may have worked at a higher temperature
Or low temperature.
or a lower temperature. I guess you could try each one again, but that would, I don't know.
There's a technique.
I don't know.
It's called gradient PCR. And we have 2 of them in the lab. You would you would check all the gradients for gradient PCR.
Okay.
I just wanted to let you know. I
You
think you did what you're supposed to do.
You can tell them too about the weirdness with that. So we got this plasmid from another group,
Alright.
and you can tell them about the it's supposed to be kanamycin resistant. You can tell them about that.
It was supposed to be kanamycin resistant, so we made a bunch of plates so that they had the kanamycin in them. But it turned out when we used the kanamycin plates, nothing grew. even though it was supposed to be kanamycin
It's
resistant.
positive.
Right, so then he just randomly tried to do it on an amp plate, and it worked. So I was labeled wrong with the kanamycin resistance, so then we almost considered maybe that it was the wrong plasmid altogether.
Yeah.
But then we did some more restriction
So
diagrams.
how do you solve that problem?
Just used amp plates, and then
No.
we tested
No.
to see
Suppose you don't know
You
what you
don't-
got.
if you had
What
the
are you
wrong
gonna
thing.
do? So you got a plasmid, you don't know what you got now.
Right.
You don't know if it's amp resistant, is it kanamycin.
Mhm.
How do you figure out we got the right plasmid?
Well, you could sequence it and see if it was the right thing.
Very good. The only thing you can do,
Yeah.
I don't know any other way.
Yeah.
Sequence the darn thing is if it's the right one.
Now that you had a week as a molecular biologist, do you think that when you graduate high school and go to college, you might major in molecular biology?
I want to major in biochemistry, so.
Okay, biochem, yeah.
Yeah.
I have a very weird question.
Okay.
Really esoteric question.
Okay.
So why in the world 50 million people will be lactate deficiency? Why would it be that way? Evolutionary, wouldn't you repair it? You think Darwinian mechanism will just repair the darn problem? Why they don't have this problem? Why we have this problem in the first place?
People aren't supposed to drink milk when they get older.
That's a
Only
good
supposed to go when
answer.
they're babies.
Yeah, that's good.
Only babies, yeah.
Babies have problems.
Oh, yeah.
I have genetic background in lactation. My son had it, my daughter doesn't have it.
The
So,
way
Doctor-
mutations work.
I have a theory on it, he knows.
Yeah, doctor, tell them what your
Yeah,
theory
you
is.
go ahead.
No, go ahead, it's your theory, so you should tell them.
See, like sickle cell save humanity.
Mhm.
See, the reason we alive, we all here in this room, because of sickle cell.
Mhm.
See, if that man had never left Africa, wasn't the sickle cell. Malaria would have killed everybody.
Mhm.
Because of this deficiency, man survived. I bet there was some parasite worm, I believe, which was killing man. And people developed deficiency, lactate deficiency, kill the worm, because you use lactose to eat. You make it deficient, you don't have a problem, just purge it out, you have diarrhea, worm cannot live in your body. I think we survive because of that. It's the end product of the genetic defect which saved like sickle cell. I think this is one of it. I believe, I don't know for sure. Somebody had to do research on it.
Thank you very much.
That is excellent.